Hello and welcome to Pep Talk with me, Mr. Pepperell. In this episode, I'm thinking about electrical energy and how much it costs us. By the end of this episode, we should understand what is meant by a kilowatt hour, how we can work out the energy used by a mains appliance, and how we can work out how much it costs.
So when you switch on an electrical appliance like the electrical heater that I've got here, how do you know how much energy is actually transferred from the mains? Well, you can calculate it if you know two things. Firstly, you need to know the amount of time you've used it for, and secondly, you need to know the power supplied to it. And these two values can be used to calculate the energy with this equation. Okay, so power measured in kilowatts multiplied by time measured in hours is equal to the energy transferred. Okay, so we could calculate that the energy of a 1 kilowatt, remember 1 kilowatt is 1,000 watts, so a 1 kilowatt heater that has been used for an hour we can work out how much energy has been transferred there. Now, we'd expect the answer to this question to be an amount of energy in joules, because joules is the unit of energy. However, joules are something really that the general non-physicsy public doesn't know very much about, okay? So we're going to use a different unit. What we're actually going to say is, if we use a 1 kilowatt heater for 1 hour, we've actually used 1 kilowatt hour of energy. That's what we've got here, 1 kilowatt hour of energy. So a 1 kilowatt heater used for 1 hour uses 1 kilowatt hour of energy. So when we're talking about the amount of energy transferred from the mains, we actually use the unit kilowatt hours. Okay, and we can define a kilowatt hour. Kilowatt hours are the unit we use to measure energy transferred from the main supply. So let's just have a quick go at using that equation for working out energy in kilowatt hours using the formula we just looked at. So my question here is saying to me, a 0.5 kilowatt appliance is used for 10 hours. How much energy has been transferred from the mains? Well, this would be a 3-mark question in the exam, so my first mark is going to come from writing down the equation I'm going to use. Power multiplied by time tells me the energy that's been transferred. My next mark is going to come from substituting in my figures. So my power was 0.5 kilowatts and the time used was 10 hours. So it's a simple sum really. 0.5 times 10 tells me that 5 kilowatt hours of energy have been transferred from the mains. Now, you may have realised that the equation we've just used here, energy equals power multiplied by time, is just a rearranged version of one that we met in the last video where we looked at electrical power. And you're right, all we've done here is just use different units, okay? We've used kilowatts instead of watts, and we've used hours instead of seconds, basically. We could actually use this equation, the same one, energy equals power multiplied by time, with our original units of watts for power and seconds for time, if we wanted to work out the energy that had been transferred in joules instead of kilowatt hours. So let's try using that now. My question says a 60 watt bulb is left on for 1 minute, okay, and I want to know how much energy is transferred. So pause this now, use the calculation, find out your answer, then start me up again and see if we get the same answer. So hopefully you've restarted me after you've done your calculations. Let's try it out. So first of all, my first mark is going to come from writing down the equation, energy equals power multiplied by time. Okay, and the second thing I need to do is substitute in my figures. So I've got a 60 watt bulb and my time was 1 minute, but hang on a second, remember what we're doing here, okay? What we're saying is we've got power of 60 watts and my time, this time we should be measuring in seconds. So right in 1 minute there is going to be no good for me. My time needs to be in seconds. So 1 minute is actually 60 seconds. Okay, so I'm going to do 60 watts multiplied by 60 seconds. And this is going to be the final part of my calculation. Well, 60 times 60 is 3,600. And this time we are measuring the amount of energy in joules. So now we can calculate energy transferred in both joules and in kilowatt hours. How do we actually pay for it? Well, it's all to do with a little box that's either by your front door somewhere or under your stairs or in your house somewhere, and that box contains one of these things. It's your electric meter. Now yours might look a little bit different if you've got a slightly older one. It might look something a bit like this with little dials that are going around on it, or if you've had some rewiring done in your house in recent years, yours may look a little bit like this one here with a digital readout. Okay, now if you go and have a look at that, obviously pause me first, don't just leave me talking to myself, okay? What you'll be able to see is that the little numbers, either here or the little hands on the dials or this digital readout, you'll see those little numbers are slowly going up. And those numbers are actually the number of kilowatt hours you've used, and they are what is used to work out your electricity bill, and it's what your electricity bill is all about. So here's a example of electricity bill, and I'm going to zoom in on this little bit here so we can see in a bit more detail what that bit there says. Okay, so I'm just going to make that bit a bit bigger so we can actually see the numbers, because what happens is a little man comes around your house and he writes down how many kilowatt hours are currently reading on your meter. So he'd have written down this first number here, so in this case it's 65216, okay, and he writes that number down. Then 3 months later he comes back and he checks it again, and he writes a second number down here, so we've got 67139. And what he does is he takes his first reading away from his second reading, and the difference is the number of kilowatt hours you've used. Sometimes on your bill it says units instead of kilowatt hours, but they actually mean the same thing. So he works out the number of units or the number of kilowatt hours you've used on your bill. So now I know how many kilowatt hours I've transferred or how much units of electricity I've used, but how much do I have to pay for it? Well, all I'm going to do is simply multiply the cost of 1 unit or 1 kilowatt hour of energy, which is 9.2 pence. I'm going to multiply that number by the number of kilowatt hours I've used, which is the difference between my current reading and my previous reading. So let's have a little look and see if we can work that out. Let's move this up here out of the way so we can actually have a look. So my calculation is the total cost of my bill is the number of kilowatt hours I've used multiplied by the cost of 1 kilowatt hour. So firstly, how much have I used? Well, I get my current reading, 8,459. I minus my previous reading of 7,711, and that tells me I've used 748 kilowatt hours of energy. Okay, so now what I'm going to do is take that number and multiply it by the cost of 1 kilowatt hour. So 748 multiplied by 9.2 pence is 6,881.6 pence. But of course I'm not going to get my electricity bill measured in pence. It means the same thing as £68.82. So you can see all they've done is they've rounded up that last penny there to squeeze every last penny out of me.
So that's everything we need to know about using electrical energy and calculating the cost. Any problems with that, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.